Welcome everyone to fine low-level Linux development here live on our channel. What is better to size optimize the heck out of all our scripts and glue and stuff for the PS3? Of course, optimizing even more out of that for the OLPC. Of course, yes, whatever, but a little bit win-win, making our T2 Linux stuff better for everyone, right? Turns out, so what is the problem? The problem is it didn't quite boot. It turns out, the previous video I blamed upstream kernel, but it turns out it's probably more some size limitation, because I now could get 5.17 even to boot, but extremely configuring the config down even more. And also with like a larger initrd stuff starts to corrupt significantly. So I like just yesterday and today and stuff, like a little bit as a side project, built here plenty of kernels in initrd. So it starts to boot now. Well, it booted earlier, but it never initrd with stuff missing and corrupting. So I basically further squeezed everything I could out of the initrd, making it potentially better for everyone. So another issue is with our initrd, and this is the cool stuff of, I didn't even expect I need or could make this stuff better. By the way, also we probably wanna SVN switch maybe. Do I have this in the history? Potentially, no. Not that we accidentally commit that wrong. So what is stuff we can optimize here, or I could optimize already, basically summarizing what I've done and committing this for everyone to use. So we have here this reading files and variable thing, and the issue is if something fails. So the issue was also when it started to boot, like maybe yesterday or maybe last night, the initrd wasn't working. And one super annoying thing is, like, if you're out of memory on the PS3, on the OLP, ironically the OLPC has as much memory, like nearly, except VRAM, 256 like the PS3, yay. So that is kinda like main CPU, the same thing. So if something fails here or goes wrong, for example, mount was missing, I'm not entirely sure yet what's going on, because no proper debug. This is the thing with random corruptions, right? If some stuff is corrupting and you don't get some proper outputs, then like you need to meditate a lot. Basically, like each time, like previous video, right, on the main channel, perfect code, right? Each time code is not perfect, like here, like I have no freaking heck what's going on. Maybe some open firmware load limitation, some memory corruption, like stuff overlapping, like I don't know yet, right? That is the thing with silent corruption. If code is not perfect, then you waste time of all the hundreds or thousands of kids and people in the world who want to keep OLPC or PS3 running. Like, yeah, memory corruption, like not perfect code, like a recurring theme. Not perfect code, freaking waste of time for everyone. Speaking of which, making our code more perfect, right? I didn't really quite, I mean, being honest with ourselves, our code could also have been more perfect. That is the thing, right? What I said on the main channel there, perfect code. If your bar is not perfect code, then you will never, you will never reach, not never, but usually you don't reach your bar, right? You aim for something and you try very hard and you thought you reached it, and then later you're only like a month, a year later, like out at customers, you noticed, of course it's not perfect, right? There's always some bug. But if you already aim for like perfect code is too difficult, too expensive, our bar is like, yeah, YOLO, whatever, barely working, then they are double, triple, and like magnitude more bugs in there, right? In our case, I didn't quite, I mean, I kinda knew that. The problem with that is it errors out instantly. So that is like some short form of, not even sure how you call that, but basically, I would actually need to read the source code. Earlier I used cat here, like cat and stuff, until I eventually, like reading the freaking manual, figured out you can directly read files, and since then I use that. So the main, I mean, it's super neat, you don't need to fork cat. But the issue is, if this file doesn't exist, which usually it does unless there is something going wrong, right, then this errors out. And I improved that already. So how to improve this? Simply surrounding this with some if conditional, right? And the only thing is we have this here more. We have this for command line, and then here we are so smart, only reading the kernel command line to parse root init and swap out of there once. And then somehow I copy and pasted that here later, adding this resume code pass. And here we read proc command line again, right? So while it not only hardening that, by the way, this is not all, right? I see already some people liked it already, but while it also cleaning the code, sure, this works and stuff, but a little bit more perfect would of course be using the same already cached command line variable there, because grouping that here, factoring that out and having this, if this stuff mounted properly, because in my corrupting memory case here, at least I somehow didn't mount, and then all the stuff here fails already. And so the issue with it is you get the problem is if our init errors out because it can't open the proxys kernel OS type here or any other stuff, then what happens is that the init exits and then the kernel is like, oops, kernel panic, our freaking init exited. So, and then you can't debug, right? The problem is then it wastes even more time of my time, because instead of that I can like hack away on the keyboard and fiddle around there and read some messages and stuff, like the kernel is dead, right? In my opinion, in my microkernel we need to have a more intelligent setup of failing and debugging and giving the freaking guru meditator some means of exploring this bit corruption. So anyway, coffee to stay awake. I improved this already, and then we have more improvements. Then I thought, and this is the crazy stuff, right? I optimized the heck out of it, and this is also why do I use my own initrd, right? First of all, there wasn't a standard, and everyone wrote their own initrd infrastructure stuff, and in the meantime, even if there is some random standard somewhere, maybe that someone shares, although I think most distributions probably still roll their own, but then most people write it so huge that I don't even want to use it, right? I think still proud that our stuff is quite readable and compact and stuff. Sure, other stuff might be more modular. Maybe someday we add a little bit modularity in there, that maybe in the middle we execute etc initrd or something, but until I didn't really need it yet. So, but if we ever need it, of course we can always, as seen here today, we can always make it more perfect. Where is our build? So I usually test the stuff directly in build. So this, copy this mk initrd. Oh wait, initrd init. Although we can initrd init here. And so that is what I edited already. So here's the side project and mk init. Did I? I'm not sure if I saved it yet. Yeah, so wait a second, this is somehow older, so much to that. Alright, but I changed there. Okay, need to merge that a little bit, so much to... Yeah, if you run a larger project, like obviously your Linux distribution is, then you have branches and tags and merge conflicts and stuff. So let's see, so is that even somehow, wait a second, somehow, why is that, did I not save it there? Don't tell me. Temp t initrd. Maybe I didn't finish editing it there, initrd init. So what I have here now, check for proc command line. I didn't bother to check all of those. If we have command line, then we probably should have those. I mean, very theoretically, I mean, this is of course only a status printout. I wonder if ideally we should check presence of those files and welcome everyone. Glauco says, find initrd tricky, any good resources? Well, I guess the kernel documentation, otherwise, shameless plug, our most minimal stuff should be quite readable. Basically just one initrd and one initrd, basically the T2 init, mk initrd package, but otherwise of course init rd kernel documentation. But this is also yeah, I mean, we don't need more. I mean, this is, other people have 10,000 of lines of code, right? And it's just like, how much is that here? It's like, those is init. Yeah, oh, by the way, this needs to be commented out. But yeah, otherwise, if you later find better resources, always leave comments below, right? I, in the meantime, sometimes even post comments below my own videos, just using my own YouTube channel as resource, knowledge base and stuff. So what I've done here is, so moving this command line out here, checking and like also only printing this status out if this per command line exists. This code we moved there, and then also resume using the same pattern here of command line, so not reading that in there again, not for the open read close optimization, but for the error path notification, so that if something goes wrong, this stuff doesn't error out and we get a freaking debug shell. Here I had to change this slightly. Also, this is funny, the first time testing, more testing, right? The first time I didn't write this with this extended shell testing here, and because we don't use bash because humongous, we use pdksh, the public domain current shell, just for the memory stuff. Yes, it's old and who knows security and stuff, but we don't run this as the main shell, right? It's not so much security when it's just in the initrd. But so in bash it works with just testing that here in pdksh, it errors out for needing an expression there so much too. If I wouldn't have tested that, I would have committed that without that, and then it would have not worked. So resume, so yeah, there is that. So change that a little bit from resume. Yeah, testing that we have resume in there and it is not no resume. So now we test, now we use the same pattern. Resume equals command line stuff, removing leading and trailing stuff for performance, parsing assignment stuff out of there, the kernel command line. And then if it's set, I hope I didn't really test that it works, but I mean, I don't really use it, but anyway. The other thing, the next optimization is, then I thought, why stop there if we can make it even better? So first of all, I noticed we have, for the P3 stuff, earlier we only had one initrd, because one initrd is certainly like my own personal preferences of a fully modular kernel, like as little as possible in the kernel and everything as a module, so that you optionally load that. So only, you need it anyway optionally, right? If you want to generically boot it on anything that anyone might throw on our precious T2 Linux distribution. And then also it is actually more flexible, right? If you need to squeeze that down for some OLPC, you don't need to rebuild the kernel. You have the most minimal, hopefully, kernel, most minimal except SMP. Also maybe we should build the 486 kernel without SMP for a little bit more space saving, because who has a 586 with SMP, right? Maybe we should do that. It's a little tiny. Why didn't we quite do that, right? I mean, yeah, anyway, maybe we should do that. But so, the other thing is, so for the P3 stuff, I made a minimal initrd flavor. I only realized with the OLPC, like basically hour after hour, squeezing the heck out of the bloody kernel initrd to finally avoid this memory corruption or whatever is going on there. Memory corruption or load limitation or whatever. We can also further optimize that, because we find that here, right? So I was thinking, previously we have just run find, like find for this piping that to CPIO, because CPIO needs a list of files, because it's good old Unix stuff, usability is a little bit, leaves a little bit to be desired. And then I thought, wait a second, why don't we sort this stuff? And this is the attention to detail, right? I mean, the attention to detail, even with all of my YouTube work, I've not improved or implemented the last years. But yeah, why not sort this stuff, right? I experimented a little bit. Sure, you could like find and sort and stuff that, but the best thing I came up with, like keeping it stupid simple, because so first of all, we even have the proc dev and this directories in there. And if you run it, so we have run it like that, I think. So as you see, then the dev is last, right? So if we have not enough memory, the kernel extracts the initrd, the bootloader has truncated it or memory clobbered that, the Linux kernel can't compress it fully or something, and not sure, actually I didn't test what the kernel does. I only see on the old PC it's not all there for whatever reason. I would hope the Linux kernel, of course, it could always be we optimize out of that and that at the end of the Linux kernel panics, but it doesn't panic on the old PC, whatever is going on there. But sorting this a little bit, so this is how we run it. So then def is last. Also the sorting is a little bit different. Why is it different if you run with a shell wildcard? Because in this case, the shell is already creating this, expanding this wildcard. This is why it then, whatever the shell does there might be alphabetically sorted or whatever your shell is doing there. And that is also not ideal. It's slightly better than because sorting bin and then def. So you need the binary things anyway and then def, but the only thing is then we still have proc and this in the end. And I thought it's actually the best optimization. Did I even run it? Did I not? Here. Maybe, probably here. Init def proc, just need to check that way, probably like that. And so with that simple trick, we can control that we first have the init script because we definitely need that. In any case, then the def proc this also should be, I mean, very theoretically we could even, not sure if it compresses a tiniest amount better if we say proc def this, because I saw that already the compression was also some bytes smaller due to the sorting of that, just potentially grouping. I mean, obviously the order of your data, also the redundancy influences the compression. So if you already group this redundancy, for example, in binaries and libraries for all the executable code, also this is not my intention here, but obviously it influences that, right? So it could also here, for example, the pattern layout of directories potentially, maybe in that order, just form maybe 1 byte shorter compression, who knows. So init proc this def, then the binary things. I have here binaries first because you could think, hey, why not the libraries first? But the libraries are the bigger part, and the libraries include the kernel module and the firmware. Although that sucks a little bit. In the long term, it would make even more sense to manually control, because user firmware unfortunately would compress first. But yeah, we could further improve that. For example, manually listing all the lib stuff without firmware. Although personally, I'm not the very greatest fan, to be honest, that the kernel firmware, the kernel modules and the firmware live in lib. That is not an ideal place, but anyway. So let's set standard lib stuff sorted to. Let's just, I had here def proc this def. Let's see what is, so what did I had here? Original and sorted. What did we got here? You see, it's not much, but it's some, hey, it's 1K smaller. Or is it? Wait a second. 289. Oh no, it's not 1K smaller. It's only 50 bytes, but it's 1K smaller than another sorted variant. This is probably fine without something. Anyway, 50 bytes, not much, but for me it's more important that we don't error out. I could, how large is, I mean, the firmware is very much not ideal, so we also have modules, LM at least. For example, the library should come before modules. We could actually, it would still be beneficial to have the modules at the end. We could actually CPIO extract set standard D. So many initrds, darn it. 52 clean build x86 boot init mini initrd cpl, and let's try that again without extracting it, just to see. Yeah, in an ideal world, why is LM, why is slightly different. So this is still not ideal. That sucks a little bit, to be honest. Why would you, strange. Does find not sorted? Manually list all the stuff so that we first, this gets a little bit tricky. I'm not sure if, with perfect code. Again, I would say, like, it's still, I also know we have some drop frames. Did this recover? Darn, 500 drop frames, so much to that. This should recover. Bloody Vodafone chip. I would still say, like, maybe, certainly with a comment, but basically first modules and firmware. The only thing is this, it should only be lib, but if we A2 KL, wait, I wanted exactly the opposite. What I even do here? A2 L M N. Wait a second. You see, so quickly you get bugs. E F G. It's a little bit near. I hope actually the character classes work like this. Maybe I should read the freaking manual. I'm also not sure if that expands to, maybe it could potentially be implementation defined and depend on the shell whether that expands as written or as regular expression created. But I would even, if this either is implementation defined or whatever, I would still say, okay, usually we of course don't run out of memory. For me it's enough to sort it mostly, so much to my topic of perfect code, right? But there's also a limit of how much quirking and surrounding. I will certainly not write some, okay, we could actually make this two expressions. That probably is simple enough to first have the modules and then the firmware to make really sure actually maybe it's actually worth it, to be honest. But otherwise there's also a limit of how quirky stuff should become. So A, E, F, A, B, C, D, E, F, G, K, L, M, N to set. Of course, most of these files we don't have there. We basically should have nearly only libs in there, but as we do that already, okay, don't have F, that sucks a little bit. Is this an exit code? This is an exit code, shit. Yeah, so much to that. Wow. Okay, maybe, because we obviously don't want a custom. Do we have firmware? I have the feeling this is creating a regular expression and... Oh no, we don't have... right, we don't have firmware right now. Okay, fine. It's good enough for me, to be honest. So yeah, libs first, and then the modules, as you see already, all the modules, these are the most minimal modules, right? As soon as you have just the tiniest amount of... the modules and firmware are huge, right? I think on our standard, like most general bootable default all modular default initrd thing. It's probably, well, the whole freaking initrd is compressed 18 megs or something. So, and actually we could, for illustration purposes, actually set standard compressor regular thing of initrd and do that again, and then you see what massive amount of modules. So I guess the firmware is first, so it's probably creating here. So what I kind of sort of expected. Yeah, would be tiny little bit, although we don't have the most firmware in there, to be honest, for the most part anyway, so yeah, whatever. But yes, this is just a massive amount of potentially, sure, we could create even more variants, but eventually that was the limit. What I actually would love if you could stack firmware initrd files, so that you could have a base image and load multiple, but the Linux kernel and bootloaders don't have the possibilities. And you could load the kernel, base initrd, and then additional network and other modules. But yeah, I can't rewrite all of Linux. Eventually I need to write a microkernel too. Not lose my sanity here eventually. Anyway, so yeah, let's commit this too. So that is that here. Init all of that stuff. Okay, initrd. And then I also need to compile. That should work like that, right? Find also sorted priority in case of out of memory. Yeah, this is the kind of stuff I totally didn't expect, that I optimize this stuff in this day and age, but here we are. And wait a second, there was one more thing that I nearly forgot already, which is, how do we do that now? Diff z1 to, because I also optimized already dropping even more files here from the minimal image here of, was it not here? Where did I overwrite something? Did I? This is also the wrong image. This is probably earlier, so much too fast tab completion. Here there's optional things, so maybe actually we save that here, and so because this is other upstream changes, and what I want is here this UDEV stuff, because I realized we neither need kmod modprop, because like a decade ago we needed that, but nowadays it's built into UDEV. At least I think it was. Anyway, if you want the most bootable stuff, it's certainly worthwhile to save a couple of more hundreds of kilobytes, moving this optional file set to minimal, so that kmod modprop insmod block ID become optional and not included if minimal. It's like, yeah, when even I didn't expect I could optimize even more. Oops. I think it was like that probably, yeah, that works like this, no backslash, just double checking. Usually I actually should test that, but I hope it's fine. Usual famous last words, always when I say I hope it's fine, then there will be syntax error somewhere in there. Yeah. And this is also a recurring theme of this couple of lines, although in total with the other file, it's actually, this again took some hours before this live stream to sort out and think and test, especially limited by the amount of memory corruption and rebooting here on the old PC. But yeah, this is how you make your project, or in this case Linux distribution, better, a little better every single day. And oh wait, initrd, this is also so much to double checking, of course. This is also strange, I'm not even sure. This I added only for debugging because I didn't have a debug shell, and somehow the first time this still didn't work. So there are really extremely strange things going on, because I also don't quite understand how this exec bin sh also didn't work. So even then, this is why I added this ls stuff there, because it's running as bin sh, right? Sometimes even 20 plus years later, with all my experience and everything I've seen, I've no idea how it could be possible that we have the shell pdksh bin sh, that's a symlink. How it is freaking possible that this is running, and then at the end it execs bin sh for you, no read, but we don't scream here the debug shell, and then the kernel loops this was like couldn't execute bin sh. That is really crazy, to be honest. But anyway, the old PC saga is not yet done. I'm also not yet sure what limitations there are. I only know I squeezed the kernel smaller and smaller, and at the end it still didn't work until I had... Did I mount it currently? No, I didn't. It's plugged in there. Nothing like testing with plugging in USB stick around here. Poor little front panel USB. So this is the only state that booted, which is 2.6 meg for the kernel. So this is, yeah, and 1 point, it's super tiny, right? So I'm not really sure what the limits are. I only know, like, before I squeezed it down. So previously the kernel even was 4 point something meg, so like basically half the kernel there. But yeah, crazy stuff. We could actually, one last thing, check. So the old PC is totally not done, right? It's just one step. I still need to figure out what exactly is going on there and if it can be larger. And currently I don't even have everything I need in there, because the last thing I even configured out MMC. So right now I couldn't even mount a root file system, even if there's some red overlay that I immediately noticed when I live streamed that it stopped live streaming because now I don't know how many drop frames missing. But anyway, we were mostly done anyway, so I hope you found this interesting, learned something. Don't forget to like, subscribe. Oh cool, we also have 411 drop frames because this is, of course, can't make this stuff. Anyway, see you next time.